Day 456 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2561, rearranging fruits. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You have two fruit baskets containing n fruits each. You are given two zero index integer arrays, basket 1 and basket 2, representing the cost of fruit in each basket. You want to make both baskets equal. To do so, you can use the following operation as many times as you want. Choose two indices I and j and swap the ith fruit of basket 1 with the jth fruit of basket 2. The cost of the swap is the minimum between basket 1 of I and basket 2 of j. Two baskets are considered equal if sorting them according to the fruit cost makes them exactly the same baskets. Return the minimum cost to make both of the baskets equal or -1 if impossible. Alright, y'all, so that may seem a little bit confusing at first, so let's take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input basket 1 equals an array of integers 4, 2, 2, 2. Basket 2 equals an array of integers 1, 4, 1, 2. The output is 1. Explanation says swap index 1 of basket 1 with index 0 of basket 2, which has a cost of 1. Now basket 1 equals an array of integers 4, 1, 2, 2, and basket 2 has an array of integers 2, 4, 1, 2. Rearranging them, both the arrays make them equal. So let's break this down one step further, y'all. So it says right here, we're going to swap index 1 of basket 1 with index 0 of basket 2. So that means we're going to take this 2 in the basket 1, which is at index 1 of basket 1, and swap it with this 1, which is at index 0 of basket 2. So when we swap these two, when we swap this 2 with this 1, we get this array of integers 4, 1, 2, 2, and we get this array of integers 2, 4, 1, 2. As you can see, if we add both of them, they both equal 9. This equals 9. And if we were to sort them, they would be the same thing, right? Which is really what we're worried about after sorting them. So two baskets are considered equal if sorting them according to the fruit cost makes them exactly the same buckets. So if we sort this bucket, if we sort this bucket, it's going to become 1, 2, 2, 4. Sorry, y'all. And if we sort this bucket, it's going to be, it should be, sorry, y'all. If we sort this bucket, it should be the same thing, right? So, boom, we sort this bucket. Once again, it's going to be the same thing. It's going to be 1, 2, 2, 4, right? So that's what makes them equal, because when we sort them, it's going to be the same thing. So that cost us $1 because the cost is, what does it talk about the cost? It says the cost of the swap is the minimum of basket 1 and basket 2, right? So in this case, the minimum of the swap, right, we had a 0 and 2. We had a 1 and a 2, sorry, 0 index 0, but the value is 1. So we had a 1 and we had a 2, right? 1 is the minimum of the two elements that we swapped. So that means that's how much it's going to cost. It's going to cost $1 because 1 is the minimum. So we return 1. Now, I hope that makes sense to y'all. Let's go ahead and take a look at example 2. Example 2 is an example of where it's impossible to make both baskets equal. So in example 2, we have our input basket 1 equals an array of integers 3, 2, 3, 4, 1, and basket 2 equals an array of integers 3, 2, 5, and 1. The output is -1. Explanation says it can be shown that it is impossible to make both baskets equal. So as you can see, there are no elements that we can swap that will make both baskets equal, because this basket, as you can see, this basket, if we swap any of these elements, they all have the same elements, but this basket has a 5 and this basket has a 4. So no matter what we do, there's always going to be a 5 or a 4 in one of the baskets, no matter what we swap, which will make it so if we sort them, it'll never be equal. There's no way for us to ever make it equal for that reason. So since that's the case, we are going to return an output of -1 because it's impossible to make the baskets equal. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all. Let's get into it. First thing we're going to do is we're going to create a dictionary to track the net difference in fruit counts between basket 1 and basket 2. So to do that, we could just declare a variable called m. We can say m colon, that's going to be a dictionary of integers. So square bracket int colon int square bracket, and we're going to initialize it with a blank dictionary like this. Boom. Now we need to count the occurrences of each fruit in basket 1. So we're going to say for C in basket 1, we're going to open up the brackets and we're going to say m, open up the square bracket C, comma, default, colon 0, come outside the square bracket and say plus equals 1. So what that's going to do is each time we see a fruit in basket 1, we are going to keep track of how many times that fruit appears or how many times that cost appears, and we are going to add 1 to this default value of 0 each time. Boom. Oh, sorry. Then we're going to come outside of this for loop, and we are going to subtract the occurrences of each fruit in basket 2. So we're going to say for C in basket 2. This time we're going to open up the bracket and we're going to say m square bracket C, comma, default, colon 0. This time we're going to say minus equals 1. And it's going to do the same thing, except this time it's going to subtract. Instead of up here we are adding, down here we're subtracting from basket 2. Boom. Now the swaps will count how many swaps are needed, and res will store the total minimum cost. So we need to create a variable swaps, which will once again count how many swaps are needed. So we can set that equal to 0 to start, and then we could do res, and that will store the total minimum cost. So we can set that equal to 0 as well. Boom. Now we need to check if each fruit type count difference is valid. So we're going to say for, open up the parentheses, C, comma, C and T, come outside of that, and we're going to say NM. We're going to open up the brackets, and if the difference is odd, it's impossible to balance the basket. So we're going to say if C and T mod 2 does not, or is equal to 1, then we're going to open up the brackets and we're going to say return -1. Boom. Now we're only going to consider positive differences or extra fruits in basket 1, and count divided by 2 is how many of that fruit need to be swapped. So we're going to come right here outside of the if, and we're going to say swaps plus equals max, open up the parentheses, 0, comma, C and T divided by 2. Boom. Now we need to sort the fruit types by their value in ascending order. So for that, we're going to come underneath this. Outside of for loop, we're going to say let M1 equal M dot sorted. We're going to open up the parentheses, say by, colon, open up the brackets, $0 dot key is less than $1 dot key. Boom. Now we need to try to perform the cheapest swaps first. So for that, we're going to come underneath this and we're going to say for, open up the parentheses, C, comma, C and T. We're going to come outside of the parentheses and say N, M1. We're going to open up the brackets. and we're going to take as many swaps as needed, but not exceeding the remaining swaps. So we're going to say let take equal min, open under parentheses, swaps, comma, ABS, open under parentheses, CNT, come outside of that and divide that by 2. Boom. Now each swap cost is either the fruit value itself or twice the smallest fruit value in all baskets, meaning a cheaper alternative. So we're going to come underneath this and we're going to say res plus equals take times min, open under parentheses, C, comma, M1 dot first exclamation point dot key times 2. Boom. Now we're going to reduce the number of remaining swaps by coming right here, and we're going to say swaps minus equals take. Boom. Now all we have to do is return the minimum total cost to make the baskets identical. So we could come right here and we could say return res, y'all. Boom. Now that should be all she wrote. That's all the code. Let's go ahead and give it a run before we submit it. Let's see, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 27 milliseconds beats 100% of users. That's what I'm talking about. Those are the numbers I like to see. So with that being said, y'all, before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.